Hello, folks. Welcome to Hustle Data. This is my new channel, and in this channel, I'm going to be starting with algorithms first, and then I'm going to be discussing building projects and some data science concepts. In this video, we are going to be talking about binary search algorithm, and we are going to be discussing what is binary search, code implementation of binary search in Python, time and space complexity of binary search. So please stay along. What is binary search? Binary search is an algorithm which takes sorted array of elements and in every iteration get rid of half of its element. So for example, if you are looking for a number in 100 elements, so until that number is found in every iteration, binary search will get rid of around half of the elements. So it's similar to like finding a word in a dictionary, or when you go to a library and you're looking for a book, so you don't just go and look for every book in the library. You follow an alphabetical order until the book is found. So that's how binary search algorithm works.
Let's see how binary search algorithm works. We have a sorted list of elements with index value going from 0 to 10. We have numbers such as 7, 14, 21, 28, 35, 42, 56, 63, 70, 77, and 84. Let's see how we can use binary search to find 28. Here you can see the initial value at index 0 is considered to be low and value at index 10 is 84, which is considered to be high. Now when we add low plus high, which is index 0 plus index 10, and divide it by 2, we get the mid value, which is index 5, where the value is 42. Now we know we are searching for the number 28 and the middle value is 42. Because the middle value, which is 42, is greater than 28, our high will become middle index minus 1, which is 4. Here index 0 is still our low value, but the high value has changed and become 4. We will calculate a new mid value now, which will be index 0 plus index 4 divided by 2, and it will give us an index value of 2. Now we will check the element present at the index value of 2, and it is 21, but we are searching for 28. Now 21 is less than 28, so now our low value will change. Our new low value will be mid index value plus 1, which is 3. Whenever the sum of low plus high is odd, we usually take the integer value after dividing it by 2. So according to that, our new width value will become 3. So keep this in mind. Let's check the number present at the mid index value of 3, and we can see the number is 28, which is exactly what we were looking for. Now let's look at the code implementation of binary search. Now let's code a binary search algorithm using Python. Here I have taken a sorted list of numbers and stored them in a variable called number list. If you want, you can take your own list or generate a list of random number using Python, but do not forget to sort them out. We'll be writing a function to implement binary search. So let's declare a function and then we'll pass a list and the number which we want to search. Let's initialize the value of low, which we will keep as 0, and the value of high will be the length of our list of numbers minus 1. We are doing this because we know index value starts from 0. We'll be using a while loop because we have to constantly check for our number in a range, so while loop will help us do that better. While low is less than or equal to high, our mid will be low plus high divided by 2. We are using a round function because we only need the value of mid in integers. And we are also using mySearch variable to store mid value so that we can check the values in every iteration. Let's use the if statement to check the mid value, and if the number present at the mid index value is equal to the number we are looking for, we can print the number and the index value where it is present. If the number present at the mid value doesn't match our number, we'll pass a different condition for it. If the number present at the mid index value is greater than the number we are looking for, then high will be equal to mid minus 1, else low will be equal to mid plus 1. We have defined our function. Now in the end, we'll just print binary search implemented. Okay. Now let's check three different numbers and their position. Let's check 30, 50 and 6. Now let's run our program. We can see that 30 is found at the index value of 13 and 50 is found at the index value of 18. 6 is found at the index value of 3. So this is how you can implement binary search algorithm in Python. Make sure you give it a try yourself. This code will be available in the description, so you can check it out too. The time taken to execute each state of code in an algorithm is known as time complexity. It is not going to examine the total execution time of an algorithm, but just the time used to execute each set of instructions. And space complexity refers to the amount of memory space used by an algorithm, including the space of input values for execution. Whenever we talk about time complexity, big O notation is used to describe it. Big O notation tells you about the number of operations your algorithm will make. Suppose your algorithm can make n operations, then the time complexity for that algorithm will be O(n). Binary search takes 2 to the power n steps to find the element we are looking for, where n is the number of elements present in the array. So imagine if we have 256 elements in a list, and if we want to calculate the number of steps required to find the element, then we can take log n base 2 to calculate the number of steps. Here we have n equal to 256, then log n base 2 is equal to log 256 base 2, and therefore we get 8 steps. To calculate the number of steps in a binary search, all we have to do is to take log of all the elements present in the array. Hence, time complexity of binary search can be given by O log n.
Thanks for watching this video. If you find this video helpful, please like, share, and subscribe it to show your support. See you in the next video.